Okay, hi everyone. We are team number 1, and our topic is VR headset and optical monitor and challenge. So we have two parts. The first part is to talk about a virtual reality headset and market products. And second part is for optical challenge and solutions. And the last one is reference. So this is my outline. And first, I want to introduce the virtual reality. And next, I want to talk about PPI and PPD. And I also want to introduce the screen door effect and flow theory and some fun fact that appears on VR. And I want to introduce some VR products. So a virtual reality is a three-dimensional virtual space generated through computer simulation, in which users can explore things and even interact with them. This technology has following three basic features, 3I, and it contains immersion, interaction, imagination. When the user moves the position, the computer will immediately carry out the image calculation and return an image of the three-dimensional virtual space to the display. Virtual reality integrates technology such as computer graphics, analog computing, positioning, display, audio, and extra. It is a high-tech simulation system generated with computer aids. The screen is used to display the simulated image, which is projected on the user's retina. And the sensor is used to precise the user's rotation angle. And the computing element collects the data from the sensor to determine what the screen display. Also, a high-end computer and handles locators is needed. So what is PPI? And PPI means pixel per inch. And the teacher has mentioned before in the class, PPI determines the level of the detail and clarity in a digital display or printed material. But now, what's PPD? Well, PPI is for monitors. PPD is for VR headsets. PPD means pixel per degree. It shows the amount of pixel points per degree in FOV. And for human being eyes, and the normal vision is about 50 to 60 ppd. So if under 50 ppd, it will cause screen door effect. If reach 60 ppd, it will be a retinal level ppd. For PPI of all kinds of products, computer monitors shows 70 to 130. Smartphones is 200 to 500. And print materials is 150 to 300. But now for VR, AR technology, PPI is 700 up. So now I want to introduce the screen door effect. It is caused by the gap between pixels in a display. It makes you see through an image see an image through a window. So how to reduce this effect? You need more DPI, and more DPI leads to high resolution. But the virtual reality will cause some fun fact. Because the user's retina is so close to the monitor, so it will cause Mura and aliasing. Mura is the pixel unable to output the identical color with another pixel. Aliasing is it will cause a jagged diagonal line to show a curve. Now it's for flow theory. Psychologist Mihaly is proposed this theory in 1975. It shows a human being that has a exhilarating state that when a human being is total immersion and total involvement in the active. It also can be used on virtual reality. And now this will shows that the refresh rate and time delay will affect the immersion and involvement. For 60 Hz LCD monitor will lead to 15 microsecond time delay. So we are required 120 Hz or 240 Hz up, and it will cause less than 7 microseconds time delay. And now I want to introduce the product. It's called Meta Oculus Quest 2, but it only got 21 ppd. And the newest one is the Innolux High PPI VR, which is made by Quanchuang Guangdian. And its PPI is reached 1411 PPI, and its subpixel only got 6 micrometer. And now it's for the next one.
Okay, I believe you can see it now. For the next part, I'm going to talk about the VR optical challenge caused by the distance our eye and the VR headset. Because our eye is too close to the VR headset, and it is by nature that our human eye cannot focus any item that is closer than 7 centimeter, which VR headset monitor has an average of 3 to 7 centimeter distance. So we actually need an additional lens after the VR headset and before our human eye for us to focus on the monitor, or else we cannot see the proper image. So there's a few solutions that the market used to solve this problem. The first, besides the conventional lens, is Fresnel lenses, which is actually another conventional lens created before 19th centuries. It only uses the useful part of the normal lenses and made it very thin, so it's practically thin. So it uses less spatial for the VR headset and is very useful. However, the Fresnel lenses create a lot of optical distortion, which we don't want. And if you use, for instance, Fresnel lenses, it means that you have to have some kind of trade-off between the resolution and concentration and contrast. So it's not really a good deal, but on your budget, it is a good deal. This is the typical Fresnel lenses on the market you can buy, and it is very cheap, even less than $100 NT. And the next solution I'm talking about is the Meta solution proposed in 2020 called holographic optics. It uses the polarization to further decrease the distance between the VR headset and the lenses. So it creates a very thin VR headset. And I'm going to show you their video. It is a monochromatic optics lenses, and they're in development, and they're going to have a full color in the future. For the last lenses I'm going to talk about is the pancake optics, which is very compact and very complex for the modern design. It's the main advantage of this is uses polarization and makes the image quality really good for we to appreciate it. However, it has a low optical efficiency and is very complex for us to understand how it actually really works. And I'm not going to talk about this. And these are the few examples for the pancake optics proposed by different company. And that's practically our report. Thank you very much.